Question 6 is coming from series, and I can see this one is arithmetic progressions. The first three terms of an arithmetic progression are p squared over 6, then 2p minus 6, and then p. Part A, given that the common difference of the progression is not 0, that means it is possible for it to be 0. Find the value of p. Okay, now, we know that the first term of an AP is a, which is now p squared over 6. And then the second term is a plus d. Okay, now this one is 2p minus 6. So that means I can be in position to get d. Not so? I can be in position to get d. So d is going to be 2p minus 6, then minus this a here, which a is this one, right? So minus p squared over 6. Now, the third term is a plus 2d, which is equal to a p here. So that means I'm going to have a, which is p squared over 6, okay? Then plus 2d is 2p minus 6, then minus p squared over 6. Then this one is equal to what? P, okay? Now we can actually multiply all through. I can multiply all through by 6 because it is the denominator I'm seeing here. So that means here I'll have p squared, then plus 6 times 2, you get 12. Now 12 times 2p, you will get 24p. Okay? Then again 12 times 6 here, don't you get 72? Yes, we shall get negative 72. And then when I get 6, and then I multiply it here, it disappears. Then the 2 will multiply with this. So we shall have minus 2p squared. Not so? And then this way we shall have 6p. Now I can have everything this side such that I have the coefficient of p squared positive. Not so? Okay. Now this is p squared minus 2p squared, you get minus p squared. But then when it crosses, it becomes a positive. So we shall have p squared. Then when this one here crosses this way, it will be a minus. So 6p minus 24p, we shall get negative 18p. And then when this one crosses, it becomes a plus. So plus 72, which is equal to 0. And then here, two numbers, when I multiply them, they give me 72. But when I add them, they give me negative 18. We can see 6 and 12. Since this one is a positive, then I can make all of them negative, such that when I add them, they give me this. So meaning this one is going to be p minus 6 and then p minus 12, which is equal to what? 0. So meaning when I equate each of these factors to 0, then p will be equal to 6 and also p will be equal to 12. But we need to find a value of p. It is one value, okay, which is not going to give the common difference as a what? A 0, okay? So let's check. For p is equal to 6, what do we get? For p is equal to 6, our common difference, remember, is here. So we shall have 2 times 6, then minus 6, then minus 6 squared over 6. There are very many 6's here. So this is 12 minus 6. That will be a 6. Not so? And then here we shall get also a 6. Not so? That means if you have 6 here minus 6, that is a 0. So because we are getting a 0 here, then that means that p is not equal to 6 because it is giving us the common difference as a what? A 0. So I don't actually need to test this other one. Therefore, p has to be equal to 12. That one cannot give us a what? A 6. I mean, the common difference as a 0. But we can check it out. 2 times 12 minus 6, then minus 12 squared over 6. 2 times 12, I think that will be 24. Then minus 6, that will be 18. Then minus 12 squared is 144 divided by 6. So the common difference is negative 6. Okay, then next, part B, using this value, find a sum to infinity of the geometric progression with first two terms, these ones here. Okay, now let us find these first two terms. A is equal to p squared over 6. Our p is a 12. Okay, divide by 6. So 12 squared is 144, divide by 6. That one gives us a 24. Then R, the common ratio, is going to be equal to, no, actually, let's find the second term, the AR. AR is going to be 2p, then minus the 6. 18 minus 6, this is 24. Minus 6 will give us 18. Not so? That means common ratio is going to be the second term, then divide by the first term. Okay? So divide by the 24. Of course, by 6, you'll get a 3. Then by 6, you'll get a 4. Sum to infinity, we know it is equal to A out of 1 minus R. So what is our A? Our A is 24, then 1 minus 3 over 4. Of course, here you will get a quarter. Then if you have 24 over a quarter, then the 4 will somersault, multiplies with that 24. So 24, then times 4, that one will give us a 96. So as simple as that.